right, good morning, ladies and gentlemen. Welcome to this morning's panel discussion, Conformal Coatings, Best Practice Techniques and Applications. Miniaturization and the rise in high volume, high reliability electronics is increasing the demand for conformal coating. This panel is going to discuss some of these challenges and some of the new and emerging chemistries, applicators and techniques. I'm joined by a very distinguished panel, which I hope will be friendly. Starting from the right side, we have Marie Kaing from AB Chimie.
Morning, Trevor.
Good morning. To her left is Chris Palin from Humiseal.
Morning.
And to his left, we have Camille Siebert from Nordson Asyntec.
Hello.
Okay, and to her left, we have Phil Kinner from Electrolube.
Hello.
And then finally, we have, to my right here, we have Stefan Schröder from Peters Corporation.
Good morning.
Good morning. Okay, so thank you for joining us. I'll start off right away with my first question to you, Marie. Does miniaturization cause any selective coating issues?
Yes, of course. As the component and tracks are getting smaller and smaller and spaces are getting tighter and tighter, the selectivity of the coating application is getting even more challenging.
Right.
So the requirement for this is, of course, to apply coating material in a much more accurate way and prevent material to, splashes and go in areas that we wouldn't want conformal coating to land, in keep-out areas, for example.
Right, okay. So, Chris, does the viscosity of the material, is that important with the miniaturization?
The viscosity plays a part, well, the whole thing, including the application system. Mm-hmm. And I think the question is there a trade-off in throughput, speed, and accuracy? Do the traditional film coating, jet dispense, etc. So there are many options, but obviously speed of throughput and accuracy are two of the main things.
Right. Okay. Camille, what problems does it pose from the coating applicator point of view? Because you're working with the machines. What does miniaturization do? What challenges does that bring you?
Absolutely. So when we talk about miniaturization, the entire board is not necessarily miniaturized, but it's those key keep-out zone distances largely that are miniaturized. So in a lot of cases, we still have the balance need for cycle time and throughput on large boards, but still need that fine detail. So in a lot of ways, pairing different applicators with different strengths, one that can do most of the larger area coverages and something for fine tuning is a powerful combination. But then also once you establish that process, making sure that you put process controls in place to maintain that consistent process is really going to get you that stability in those critical areas.
Okay. Phil, a question for you. Do you see coating requirements in IoT devices?
Trevor, we get asked this question a lot, and I think the answer is really yes, but what I don't really understand is kind of the difference between IoT and any other kind of networked application.
Device, yeah.
So from our point of view, the demands are kind of the same in terms of the types of electronics that are being made and types of environments the electronics are being used in. So I don't really have...
What would it be for the coating of the sensors, or for example, in these IoT devices? I'm sure they don't need to be coated. You've got to be careful about not upsetting these.
But it's the same with any kind of networked device that's communicating with anything else. So the challenges aren't really, for me anyway, they're not really any different between an IoT application or any other kind of networked sensor agreement.
I think largely what we see is just the growth of having conformal coating in more electronics, and then with that, depending on the complication or the complexity of those electronics, how selective we need to be, how controlled we need to be, and maybe that's where we start to see some of that sophistication needed for conformal coating really come to play.
Yeah, okay. So question to you, Stefan. 80%, up until recently at least, 80% of the people that are coating haven't been cleaning. But is that on the rise? The number of people that are cleaning before coating, is it rising?
I would say that depends strongly on the industry. So there are still lots of coated electronics boards not cleaned before conformal coated. But this is where you have to save money. It's general industrial areas, automotive still. But if you go to medicine, military, there are at least 9 out of 10 applications cleaned before. So I think everybody agrees that it gives you better results at the end of the day. But not everybody or the end customer is not always willing to pay for it. And therefore, to have an additional step inside, it's challenging for a lot of our customers to put that in front of the conformal coating. But I think most won't, or most will agree, it gives a better result.
Basically, high reliability applications are doing it, and
There it is
down to, as you move
required.
down towards consumer, it's less likely.
I think also component types are becoming kind of a limiting factor for cleaning. Certain packages, QFNs in particular, are creating, and very small passives are creating more and more cleaning challenges where maybe sometimes you do more harm by actually cleaning than by not cleaning. So I think it's one of those things that it really depends on, what the nature of your electronics is. And as Stefan
I think
said,
what you're
the
saying,
industry.
so the components with low standoffs, once you get below 2 mil, something like that, sometimes you can trap the solvent in there and it does more harm than good.
And partial cleaning, perhaps. Yeah.
Marie,
I would add to what Phil just mentioned that, it's correct that sometimes cleaning might be more harmful than not cleaning. But what's important if you don't want to clean and you want to coat is to test.
Yeah.
Is to really understand and control the level of residues and the quantity of residues you have on the board, that it's very compatible with the conformal coating you're applying on top. So it's all about testing the compatibility between the chemistries of you are applying, and you should be okay. So it's all about process control, validation, and qualification. But for sure, as conformal coating manufacturer, we would prefer, in an ideal world, that all the PCB assembly would clean before coating, because that will take out a lot of the conformal coating defects that we see nowadays with like de-wetting, bubbles, cracking after environmental testing. So if you don't clean, just test.
Yeah, it certainly doesn't make sense
Trevor,
really to chop
can I just add that traditionally we talk about high reliability as being military, but as in automotive, as we move towards autonomous vehicles, that's very high reliability. And 90% of that industry is no clean.
Yes. Well, it's a good point. I would actually call automotive high reliability, but as you say, that they are not cleaning enough in that area. That's a very important point. Another thing that's happening in the cleaning side is there seems to be a trend towards plasma cleaning. Does anybody have a view on that?
Well, this is really, it's really down to the substrate. So if the substrate is good enough, is high enough surface energy for coating, there's generally no issue. In many cases, that doesn't happen. Inline plasma cleaning does do a good job and does fix issues. I guess it's kind of fixing issues that exist that could be fixed in other ways, but plasma. We do see plasma cleaning quite often.
I would mention that plasma is not a cleaning method. It's more a surface treatment method. You're not actually removing the residues from the PCB. You're activating the surface to get a good surface energy on the substrate, to get a high surface energy on the substrate, to get good adhesion, good wetting onto your PCB substrate. So the advantage is, plasma treatment is very well known in bonding application, wire bonding application. For conformal coating application, we see few customers doing it just before conformal coating when the PCB has very, very low surface energy. But plasma is a treatment, surface treatment method, not really an actual cleaning method.
You're right. It makes the surface much more easier
more
to
activate,
more
activated, so that it's more prone to enhance the adhesion of the material that you're going to apply on top.
Yeah, and I think going back to what Marie was saying earlier to do with process stability, what it really does is gives you a very consistent surface for wetting. So you tend to to kind of get a much more uniform coating anyway, and then obviously better adhesion generally. But it's more to do with keeping the process stable and consistent at the same time after time, which is what everybody's looking for.
Okay. Okay, so Camille, do you see any new approaches coming for selective coating?
Absolutely. I mean, we see innovation in conformal coating all the time, especially as the market for high reliability coating continues to expand. That really pushes the level of sophistication that needs to come with conformal coating. So that's everything from consistency on the fluid, consistency on the equipment, consistency on the boards that are being provided. And so from that perspective, there's a lot in the way of process controls and developments that we can add to make sure that we're making the entire process more efficient. So whether that's innovations not just on the coating side, but on the curing and inspection side, or new valve developments or new process control developments, all of that plays into making sure that you end up with a better and more consistent conformal coating process.
Right, okay. Anyone got anything to add on new coating methods that are being used? No?
Yeah, there's all traditionally dip coating was a thing, and there are selective dip coat systems which are pretty effective actually, and they shouldn't really be ignored. They're there.
That's true. I've seen these in some of the big contractors that are doing nothing but coating.
Depends a little bit on the size of the batches you're producing. The bigger the batches you produce, it makes sense, but the more flexibility you need in Europe, for example, you have 20 different layouts on a day and not one for 20 lines, then it makes a huge difference.
And as we start talking about the different pieces of equipment that support the entire coating process, if you're talking about new developments, then getting more information and communication transported to the original process, whether you have an ACI system that feeds back to the conformal coating system, that also really helps enhance the conformal coating process. So it saves the manufacturers from a larger amount of failed boards. It really helps improve the process, and they can address issues sooner so they can help improve their yield.
Well, that's true. Everybody's asking for data these days, so we all need traceability of the process. Let's move on to the subject of masking. It's everybody's pet hate because it takes so long, but is absolutely necessary.
I think that depends. It depends on your board, the design, the process, and the material. So, for example, if you're using Palin, then you need to be really, really good with your masking because Paralin's going to coat everything. If you're, if your board's well designed, then you should be, and the areas that are not to be masked are kept kind of plenty away from areas that need to be coated. Then you really shouldn't need to be masking.
Right.
So, for me, it really depends.
So you're saying if you're not using Palin, you can rely on the tight valve controls that you get on some of these dispensers to do tight line definition, and that's going to be enough. You don't need to mask off the areas you're not coating.
I think it's a matter of design. So I think if you design with coating in mind and the limitations perhaps of your equipment and your fluid combination, then that's really what you want. So it's a design thing.
I think to Phil's point, an optimal design is really going to give you the best first step to having an effective coating process. But on the equipment side, we really get to see how the correct tool, the correct applicator can really enhance that process. We've had customers who've come with multiple projects that require masking, which obviously is an additional step, additional labor. And with the right piece of equipment, with a higher process control capability, better edge definition, then they can get much more predictable results and can remove more and more and sometimes completely eliminate masking from their process.
Just on the time issue for masking, there are developments in masking technology as well. UV cure temporary masking reduces the time from the traditional latex type systems considerably.
Really? Okay.
Ultimately, if you can eliminate it altogether, that provides the most benefit to manufacturers.
You would think so, but when I go into some of these companies that are doing services for conformal coating, I mean, they're literally masking everything. They seem to spend an awful lot of time doing it.
But I think that's their bread and butter. I think they end up with a lot of boards that there's a reason why they end up with them, and why they're very specialised in doing that.
They see that as part of the service, do they? Yeah. Okay. Okay, let's move on to Stefan. What's the best coating chemistry for high volume manufacturers?
The whole board looked forward to that question already. Yeah. It depends. It's the focus of a lot of customers requesting it. It's going to avoid solvents. That is one of the possible focus you can have. Going that direction, you want to have it fast, you want to save energy, you want to avoid VOC. Mm-hmm. So from these points, having it for mass production very fast, I would come to the conclusion UV technology would be the right direction for mass production very fast. If we have a customer requiring 1,000 pieces an hour, there's no way to talk about 10 minutes of IR curing or something like that. We are talking about 3 to 30 seconds UV cure. So right. I think for mass production, saving energy costs and VOC.
Okay, so saving energy costs, VOC, and obviously a fast curing time is the important bit.
I have a general question for all of us. Mm-hmm. Do you see LED UV cure coming into the market?
Absolutely. So what we define as UV LED technology compared to the traditional mercury doped arc technology and microwave assisted curing system is that the LED technology has the huge advantage of energy saving, cost saving. The board's temperature are much cooler when it comes out of the board, so in terms of board handling. The other big advantage is that it doesn't generate any ozone, and also it doesn't really create any RF interference, especially with the microwave-assisted system. Right. So your energy bill on the LED curing systems has been established as being 3 times lower than compared to a traditional mercury arc or microwave-assisted lamp. Okay.
Do you have to be careful about the thickness of the coating that you put on these LEDs? Because obviously that can affect the luminance of the LED.
We're a little cross-purpose here. So what Marie was saying is the cure system.
Oh, the cure system. The LED cure system. I apologize.
I was describing the process advantages of UV LED system compared to the traditional UV system.
Just to answer Chris's question, I see a lot of people interested in LED lamps. The technology is there. The benefits are clear. I don't see many people adopting it at this time.
I think you're right. I think it's a little chicken and egg at the moment.
Yeah. So not many people adopted it, but there are lots of interest on the equipment side. But also the reason is because on the material side, the chemistries are still evolving and developed. Yes. But there are some chemistries out there that are fully developed, fully commercialized, and has been developed and really shown to be successful. So yes, it's still in development progress at various companies, but there are chemistries out there that are readily
we know also
usable.
There are still limitations due to the layout of the boards. So if you have huge condensators on the board, UV LED curable coatings would not be the first choice, of course.
Well, we're talking
about SMD components, and then it works pretty fine. It depends on the layout again.
You can cure with an UV LED lamp up to 200 millimeters, really, really high. So traditionally, yes, LED technology, you would have to cure it really close to the boards, but today there are systems in place and material in place which can be cured at really high height. So you can get away from this height restriction now.
And yeah, of course, anything's possible. But the question I would have is, what trade-offs are you making to overcome the drop-off in power that's proportional to the square of the distance? So,
There's not that much changes in the irradiance on the height, and those new LED technology have been shown that yes, when you increase the height, we can compensate on getting enough irradiance so that you can still cure it within a few seconds and the exposure.
Yeah, I think interestingly as well, we talk about single component materials, dual component materials, but there are two component UV cure materials, which is kind of an interesting step for some people.
Yeah, it's funny you should mention that, Chris. We've got a live demonstration on our booth.
So anyway, let me ask you, Chris, I mean, with the number of different applications that are opening up for conformal coating, what are the single biggest challenges that you have, or conformal coating companies have?
I think with some of the traditional materials, the solvent-based materials, sharp edge coverage is always an issue. There are ways to fix that. If you go back to when conformal coatings originated, everything was coaxial leads, round leads, through hole, and there were no sharp edges. As we get smaller, obviously the laws of physics say that you put a liquid onto a sharp edge, it's not going to stay there.
You're going to get a problem. That's where you get the ingress underneath it. Yeah. Anybody else? Phil, do you have any suggestions on what the biggest challenges are for conformal coaters at the moment?
I think it's really understanding there's so many different demands on the coatings. So different environments, different types of components, different board qualities, different board cleanliness, different finishes. I mean, and different fluxes, different pace. I mean, there's so many challenges to kind of.
They're all different.
I always kind of when you look at painting a car, for example, they go to very great lengths to prepare the surface before they apply the paints. In electronics, it's kind of like taking that brand new car, driving it through a field, and then painting it and expecting it to be perfect. And so that's kind of how I see our challenges.
Okay. Right. Okay. One last question to Camille here, and I'm going to ask you: how do conformal coaters maintain the level, a consistent level of coating in the best way?
Right. So once they've gone through that gauntlet of selecting, the appropriate fluid and the appropriate equipment for their process, customers can see issues from kind of three main areas, either from the board, whether it's clean and consistent. They can see issues in variation from the equipment, so some degree of maintenance. Obviously, the more you can automate that and implement closed-loop process controls, then the system can take care of itself. And then variations in the overall environment that can affect the consistency of the fluid. So whether you have temperature fluctuations throughout the day, whether you have humidity considerations that affect some of these moisture-sensitive materials,
That's a good point.
all of that can contribute to variations that you see in the process.
Yeah.
So the more that you can streamline and maintain a consistent process, whether that's putting a cleaning process at the beginning to make sure that you're getting consistent boards, depending on your various fluid manufacturers to understand the properties of their fluid and making sure that then you have the correct piece of equipment with the tools to make sure that you can dispense correctly to what your application requires and maintain that process consistency that you need.
Right. Okay. Well, good response there, and good response from all our panelists. Unfortunately, we're running out of time, so I want to say a very big thank you to Marie Kaing from Chimie, Chris Palin from Humiseal, of course Camille Siebert from Nordson Asyntec, Phil Kinner from Electrolube, and Stefan Schröder from Peters. Thank you very much for joining us today.